Today I'm going to be talking to you about a client of ours where we put together a solution where if we didn't have access to dynamic engines, the solution would not really have been feasible. And I'm going to be talking to you about some of the benefits that we saw that really made this solution feasible for the client. So I am Dr. Jonathan Stanger. I'm a senior solution architect and sometimes literal wizard for spatial partners, and have been known to get into all sorts of trouble, developing all sorts of unusual things, and often finding uses for technology in areas where one might not expect. And in our case, this is actually one of those examples where rather than working with geospatial data, we were actually working with financial data. And we were actually working with a vast number of on-premise repositories of financial data. And the client of ours was actually working to try and bring together vast amounts of this data so as to make it more available in a cloud-based platform, so that it was actually in a timely manner to be able to make business decisions. And so a very good adage that they used is that you cannot manage what you cannot measure. And so getting access to this data in a timely, accurate, and adaptable manner is how you can get enough trust in that data for people to be able to make those decisions. So the real challenge that we got started with is we're syncing this data from multiple different businesses, multiple different sites, resulting in about 22 different unique databases that we were syncing from two different data structures, meaning that it wasn't just a simple sync it one way. We actually had to be able to account for two different styles of data, and eventually they'll be adding more different data structures as well. Bringing it all into a single cloud-based platform, and they needed to achieve near real time. So it needed to be able to be syncing the data to have that availability so that within, say, 20 minutes of the data being created in the original data source, it was available within the cloud. And then every time we're executing an FME workbench, we're also dealing with about 9,000 records per site. So there's actually quite a lot of data that's being shifted by this service. So with all of that in mind, it starts to get a little bit of an interesting challenge. So we needed to keep an accurate synchronization into our cloud-based source of truth. And so to do that, we actually went with an upsert process. And of course, as I've been mentioning, we needed to make sure that this was occurring in a timely manner. And so we also had the fact that these are not sites from the same client. These are actually sites from different clients, different businesses. And as they add to their service, there'll be additional different businesses and different sites. And so we can't sort of say, oh, well, these ones get priority, and if these other ones are a bit slow, that's okay. That's not a possible option because all clients are equal, or all clients of the client are equal. And so as a result, we had to make sure that we were able to really process that data in a timely manner for everybody. And another part of it is that because we're syncing from one database to another on a regular basis, there's actually, and one is on-prem and the other is off to a cloud-based service, there's quite a significant network overhead in this whole process. And the whole coordination means that there's actually quite a lot of time where engines are sitting idle and not actually doing work for our customer. And the scalability of the solution was definitely a large consideration. While currently in their proof of concept, they're sitting at the number of sites being about 22. They are expecting within a few years to be able to go up to 450. And so that level of scalability of, hundreds of percents in increase in volume means that they need to be able to scale up this solution without having the cost scale drastically alongside. And as I mentioned, the sources of the data sometimes does change. And because this is kind of bringing data from one product to another product, there may actually be also changing needs in terms of the structure of the data moving from one place to another. And while that's not quite a dynamic engine challenge, that is definitely an FME type challenge, allowing the adaptability of that action so that the sync can actually be adapted as well as scaling. So the simple fact is that when we're sitting down and considering how this is going to go, a slow and steady approach just simply will not cut it. So taking some kind of sequential solution where we just chuck everything into a queue and when it's finished is when it finishes, that's unfortunately not going to work for the kind of commercial availability of the data that they need. And so the solution needs to be highly parallel to keep everything timely, make sure that we're getting the data published out to the cloud platform when it needs to be as quickly as possible. The client also needs to be able to handle burstable loads. So depending on what's happening on the source data set side, how much data is being generated that needs to be synced, that may go up and down. And also the number of clients that we're syncing, the number of target sites that we're syncing from may go up and down. And so there needs to be the ability to be able to burst up and down in terms of total volume being processed. And also cost really preferably, particularly to compete with other possible more bespoke solutions, should be minimized for any time spent just waiting for network traffic and API responses, because that's not really adding value if it's just sitting there waiting. So the real solution is dynamic engines. And this allows us to basically rev up the server whenever needed to be able to get the data processing done on demand. But I feel like I need to give a little bit of context as to just how busy this actual server was. So the way everything was configured is we actually have a control workbench that talks to a control database, and this configures which sites are going to be synchronized and how to go about launching that synchronization, basically all the custom configuration for a site-by-site basis. Now, there's two different formats that are syncing from their respective databases and then pushing all that data into a transactional database. But our customer's application also actually has a requirement to turn the normal form transactional data into a denormalized form for a data warehouse to optimize for sort of querying and application use for business reporting. So this meant that there's actually a second task running in parallel as well for the FME server, which is steadily syncing different parts of the database and transforming it in the process into that denormalized form. Classic job that FME is quite good at, but again, for that timeliness of data availability, there needs to be a lot of parallel action going on all at the same time. And so parallel processing is a key part of this solution. We've got a little bit of a rebuild of that diagram down the bottom. So 1 month's worth of synchronization from those data sources. You can see the bottom grand total for the count of all jobs executed on the server, 18,500 jobs executed in a single month. So that's demonstrating that there's a vast number of workbench tasks that need to be executed. And in terms of total elapsed time, there's actually, you can see circled there that there's 2 sets of at least 8 hours on average per day that is being used just to execute those 2 tasks. And so between those 2 and a few extras, it pretty much starts to look awfully like, oh, you might actually need 2 static engines, even if you were trying to do this in a sequential manner, just to handle 22 sites. Now imagine how much engines you're going to need to be able to do this kind of parallel processing for 450 sites. And on top of that, this would be having to surrender some of that timeliness if you were doing it in that sequential process. So the dynamic engines really allows us to be able to get the data when it's available, not have to wait for a queue and not have the vulnerability that if the volume of data and the time of execution for some of these workbenches suddenly spikes because, say, a large amount of data is coming through, then we don't have the vulnerability that suddenly the availability of that data is delayed significantly. And I think of particular interest is looking at the comparison between the elapsed time and the CPU time. CPU time being what dynamic engines would bill for versus the elapsed time being just time on the wall clock. And so you can see that there's actually quite a lot of time that's spent idle, meaning that this parallel processing, if one engine is just sitting there idle and not billing to the customer, our customer, then that's actually quite an advantage for us. So another aspect of it is the variability of the server load. So things like during certain days, perhaps public holidays, where financial data is not changing very much in the source database, we actually find that the variability of that load on the server can go up and down quite a bit. And sometimes there's additional syncing that needs to happen to get additional historic data. And so as a result, we can definitely see that if this was being done with the traditional FME engines, it would be quite a struggle to actually guarantee quality of service. Whereas with the dynamic engines, not only is it easier to scale and be able to, at very short notice, potentially without even having human intervention, be able to deal with 100 or 200% increase in server load. But you can see as well that when you put it on a graph, it becomes even more obvious as to just how much time you can have spent with the engine actually being idle. So really, to hammer home cost effectiveness, so I sat down and actually did, based on these 30 days worth of activity, did a little bit of a cost calculation, and down there in the bottom corner, you can see that in terms of how much we would be spending from a dynamic engine perspective, that's including having to have your one standard static engine in place as well. That's the approximate estimated annualized cost. And compared to having to have, say, 2 static engines that would be able to handle the occasional bursting above what a single static engine would be able to handle, means that we're effectively getting about a 30% saving in terms of cost savings for our customer. And I think the thing that really highlights it is if you're looking at the control workbench, where the average duration in minutes for the execution of the control workbench, 13 minutes. The average time actually spent doing any CPU actions is 0.03 minutes. So essentially 0. So being able to run that on a dynamic engine is almost free then. And that allows the other engines to be actually doing value-adding work, such as doing the actual work of data translation and synchronization between both the data warehouse and between our source data. And as I've said down there at the bottom, idle engines are the devil's plaything. So dynamic engines have really been a critical enabler for this application. Without it, I believe FME would not have been suitable for this particular application. They would have been far more likely to go with a bespoke solution built out of probably something like a Python code on a serverless function. And that would have locked them into some of the downsides of having actual code-based solutions rather than the FME graphical-based solutions, because the development is much harder. It's much more difficult for them to adapt to changing data needs over time. So by having dynamic engines available, not only has there been a cost saving for them, but the kind of application, which is the highly variable data use and the need for implicit scalability, means that they've been able to avoid that code lock-in problem while they're still sorting, feeling out exactly what they need to do with their product, and may very well, because of the more reasonable cost, keep FME as a core part of their solution for an extended period of time, possibly for as long as their product survives as well. So it's quite a positive outcome. So thank you very much for taking the time to listen to this talk, and I hope it's given you something to think about in terms of how dynamic engines sort of maybe changes the picture in terms of what kind of applications could be suitable for FME.